and how you can leverage Ansys Granta. Just a quick heads up, today's session will be recorded and we will not have a Q&A in the end. So if something catches your interest, please feel free to reach out. Okay, so before we dive into the tools, let's take a step back and look at why materials data matters so much in R&D and product development. In most companies, materials are the second largest expense after labor. But when engineers can't access the right data, they often over-design or even use over-specified materials. Common questions pop up all the time. So, can I perform reliable simulations? How can I reduce weight without compromising strength? And what's the environmental trade-off? These questions obviously influence the cost and the performance of the final product, and the ability to answer them quickly and with confidence highly depends on how well you manage and apply your materials information. Let's zoom in on where things typically go wrong. This illustration shows the full product life cycle from early design and manufacturing to product use. And across each stage, we see recurring challenges, including wrong material choices early in the design phase, high material costs due to overspecified selections, duplicate testing caused by missing data, and unreliable simulations that delay decisions and, of course, push back time to market. In many cases, the data is scattered across SharePoint databases, hard drives, or even paper documents in labs. You might have reports in one place, specification in another, and simulation inputs buried somewhere else. But even if that data is valid, it's sometimes hard to trace, verify, and connect to the tools you're using. And the result is an environment that's insecure, inefficient, and insular. So this is exactly the kind of environment we want to move away from. So what happens when material data isn't properly managed? This diagram represent a typical project path from early design exploration to production. And as you move forward, the investment of time and money increases significantly. So if a poor material choice is made early on, the impact usually doesn't show up until testing or even production. However, by that point, as you already know, it's costly to fix. So you might need to rerun simulations or conduct new tests. And this, of course, leads to delays and higher costs. However, making the right material choice isn't always so easy. It's not just picking a material off a list. Actually, it is a complex process because there are thousands of possible candidate materials. It's with trade-offs, of course, and it's no surprise that over 42% of companies spend at least a full week just identifying new or replacement materials. And also more than 85% of companies need to compare and evaluate multiple materials, not just for individual components, but across full product assemblies. And this is where Ansys Granta comes into play. So what is Granta? It is a suite of tools designed to manage, analyze, and apply material information effectively across the product lifecycle. There are four key products depending on your needs. First, we have Granta material data for simulation. This is our entry-level library embedded in the Ansys flagship products. Next is Granta Selector, which is an intelligent material selection tool that combines extensive property data with powerful analysis and comparison features. And then there is Granta MI, which is our material information management system, and it brings together your in-house materials data and Ansys reference datasets. I will not go into much details here because later on I will walk you through each of them separately along with some demos and case studies. Now that we have covered the available tools, it's worth taking a moment to look at the materials data behind them. First of all, we have Material Universe and JAHM curve data, which are both available in Granta MI and Granta Selector. Material Universe includes over 4,000 materials, each with complete and comparable data. So it's perfect for early stage trade-offs like strength versus cost or performance versus sustainability. JAHM curve data, on the other hand, provides over 35,000 temperature-dependent datasets. It includes properties like stress, strain, creep, fatigue, which sometimes are hard to test. And beyond those core libraries, we also offer a range of industry-specific advanced data collection. These include property data for composites, additive manufacturing, eco-design, metals, and as you can see in the slide, many more. And finally, there are also datasets specifically built to support compliance and sustainability. So we saw the tools, we also saw the materials, data behind them. The question is, what difference does all this actually make? So in other words, what happens when you digitize and centralize your material information? First of all, you can drive efficiency because by using the right materials early on, you can cut down on waste and save significantly on raw material costs. It also helps you stay agile because with a single materials ecosystem integrated into your CAD, KAE, and PLM systems, teams can collaborate better and make faster decisions. And from a simulation standpoint, more accurate materials data, of course, means fewer repeat simulation, which directly shortens the development time. Now let's dive into each of the three main products, starting with Granta MDS. So Granta MDS is actually an add-on that provides over 700 materials and more than 1,900 producer grades, including temperature-dependent properties that are essential for accurate simulation results. And actually, what really makes it powerful is that, as I mentioned earlier, this data is embedded directly into flagship Ansys products like electronics desktop, mechanical, fluent, discovery, and MotorCAD. And what this actually means is that you can add the right materials data with just a few clicks right where you are already working without needing to switch software. And also the data are ready to go because they are because this data are simulation ready, meaning no additional input is needed. So instead of spending time searching for data, you can focus on solving. Now let's see with a quick demo how easy it is to access and apply this data inside Ansys Mechanical. As you can see, the material library is accessed through the materials option in the tree on the left. You can use the filter to narrow down the list and show only datasets from the material data for simulation add-on. From there, you can scroll through the list or search for the material you need. Clicking on the material names opens up a detailed dataset, so can you review its properties. And to add the material to your project, just click the plus icon next to its name. And if you want to assign a material directly to a component, simply select the component from the project summary, go to the details panel, and open the assignment menu. Let's move on to Ansys Granta selector. And think of it as an encyclopedia of materials, but one that you can search, filter, and visualize. You can explore here technical, economic, and environmental properties for thousands of materials and use built-in tools to compare them directly. On top of that, it also includes features like Find Similar, which helps you replace materials with viable alternatives, and the Eco Audit tool, which gives quick insights into the environmental impact of your choices. And once you have narrowed down your options, you can export the materials directly to CAD and simulation tools. Now let's take a look at how this actually works. So Granta Selector is built around a systematic selection methodology. You start by breaking down the design requirements, thinking about what's the geometry and the primary loading, what essential conditions must be met, what are you trying to maximize or minimize, and from there the tool screens out materials that don't meet your constraints, and then it ranks the rest based on your objectives. Let me show you a quick case study that really highlights the impact Granta Selector can have. This case study focuses on a project to design more sustainable packaging. And actually, the main goal here was to reduce the carbon footprint of the materials used. So the team used Granta Selector and was able to access validated material data across a wide range of grades and forms, visualize trade-offs between competing property requirements, and the result was that they found better alternative materials twice as fast. And they also achieved a 10% reduction in carbon footprint while still meeting mechanical design needs. Let's take a look through a demo of how you can bring your material from Granta Selector into Ansys Workbench. You've got two simple options. The first option, if you're working in a standalone instance of Granta Selector, just run your material selection project as usual. And once you have identified your top candidate materials, you can export them as an XML file. And this file can then be easily imported into the engineering data section of any compatible system in Workbench. And the second option is to link Granta Selector to another system in Workbench, such as a static structural in this demo. And to do this, simply add an instance of Granta Selector and the solver, and then connect them by linking the engineering data cell from Granta Selector to the model cell of the solver. And from there, you can launch Selector directly within Workbench, carry out your material selection using all its tools, and again, export your chosen materials. And once your geometry is created or imported in the static structural system, the selected materials will be instantly available for assignment. Now let's explore Granta MI. So in many organizations, materials data is siloed, inconsistent, or hard to trace. And if someone asks, what data do we have on this material? The answer might take days or never come at all. And Granta MI changes that. It creates an authoritative source of truth for your materials data, where all materials IP are centralized, structured, and accessible across your organization. Different users, from simulation engineers to regulatory teams and procurement, can access this single system, but each through apps that fit their workflow, whether that's a web interface or integrated directly into CAD and CAE tools. Let's take a closer look at what it actually brings together. So with Granta MI, you can collect all your material data in one place. That includes everything from simulation models, test data, to supplier specification and in-service data. On one side, you've got your proprietary materials information, so the data you've generated and tested over the years. And on the other, you have access to a comprehensive reference library, including data for metals, polymers, composites, and so on. And this data can then be leveraged across your organization in powerful ways, from CAD and PLM integration to additive manufacturing and AI and ML initiatives. This slide highlights just a few of the key use cases that Granta MI supports. And as you can see, it's a pretty broad spectrum. So engineers can easily visualize and compare data, manage preferred material lists, and even share control data with partners and suppliers. And it's not just about convenience. This actually is that drives traceability. Let's now look at a case study of how Granta MI can bring automation and reliability. So traditionally, deriving Gizmo material cards from raw test data was, let's say, painfully manual process. because calibration steps were time-consuming, prone to human error, and not repeatable. And this, of course, meant lost time, inconsistent results, and a high risk of data loss. So with Ansys Granta MI, this workflow has been completely transformed. On the right side of the slide, you can see the as-is process. So raw test data being manually merged and calibrated. In contrast, the to-be state shows the automated workflow the company implemented. Now, the test data is imported directly into Granta MI's database. And from there, the Granta MI Python toolkit and OptiSlang take over, extracting parameters like Young's modulus, yield strength, and hardening curves. And the result is that they have cut the model generation time from 3 days to just 1 hour. And beyond speed, this brings value because um, the accuracy in failure prediction has improved. Human error has been significantly reduced, and also the simulation workflows has been streamlined. Let's move on to our final case study, and this one addresses a problem that's quite familiar in simulation. So the time and cost associated with developing accurate KM material models. When developing models for, let's say, strain rate dependent plasticity or piecewise linear plasticity, the process can involve testing up to 40 sample bars. And these tests are often conducted in parallel by different teams or departments without really have full visibility into each other's work. And this leads to high testing costs, duplication of effort, and ultimately inconsistent models. So what's the solution? The solution is a centralized shared database like Ansys Granta, Granta Ansys Granta MI. And this way, before any new testing is requested, users can check the system to see if existing test results or KI models already meet their needs. And also connected data processing tools to automate model creation, things like statistical analysis, coefficient calculation, and model fitting. And the results are quite impressive. For example, one automotive OEM saw a 40% reduction in the cost of acquiring material property data for simulation, and the same OEM also cut data cleansing time by 80% and reduced the engineering time spent on non-engineering activities. And that brings us to the end of today's presentation. Thank you very much. I hope you enjoyed. And don't miss next week's episode where my colleague Yuri will talk about Ansys OptiSlang and how you can speed up your processes and improve your workflow. Have a nice